Hey there, science explorers. Imagine trying to balance a ruler on your finger. It's tricky, right? You're searching for that one special point where the ruler stays perfectly horizontal. That, my friends, is the magic of the center of mass. This concept pops up everywhere, from the way you walk to how rockets launch into space. It's the point where an object's mass seems to be concentrated, its balancing point. Intrigued? Let's dive in. Every object, no matter how big or small, has a center of mass. This is a fundamental concept in physics that helps us understand how objects behave when they move or are subjected to forces. Think of it as the average position of all the tiny bits of matter that make up that object. Imagine all the atoms or particles coming together to form a single point that represents the entire object. It's like finding the middle point of a group of friends, but instead of people, we're dealing with atoms. Just as you might find the center of a group by averaging everyone's position, the center of mass is the average position of all the atoms in an object. For a perfectly symmetrical object like a ruler, the center of mass is right in the geometric center. This is easy to visualize because the mass is evenly distributed. But for more complicated shapes, it can be a bit trickier to pinpoint. Irregular objects have their mass distributed unevenly, so the center of mass might not be where you expect it to be. Don't worry though, we'll get to that. Understanding the center of mass is crucial for many applications, from engineering to sports. For example, in sports, athletes need to know their center of mass to maintain balance and perform better. Engineers use this concept to design stable structures and vehicles. So, stay tuned as we dive deeper into this fascinating topic and explore how the center of mass affects the world around us. Finding the center of mass is like playing a balancing game. For a straight object like a meter stick, it's easy. Just find the middle point. But what about a weird shape like a boomerang? For more complex objects, we can imagine dividing them into smaller pieces, each with its own tiny center of mass. Then, we average the positions of those mini-centers, taking into account their masses. It's like finding the average height of your classmates, but instead of height, we're dealing with positions. The center of mass plays a crucial role in our everyday lives and beyond. Think about a basketball player taking a jump shot. To maintain balance and shoot accurately, they instinctively adjust their body position, shifting their center of mass to be directly above their feet. Even rockets rely on the center of mass for stable flight. Engineers carefully calculate the rocket's center of mass, ensuring that the thrust from the engines acts through this point, propelling it upwards in a controlled manner. Section 5. Stability and tipping points. It's all about balance. Ever wondered why some objects are easier to topple over than others? It's a fascinating question that delves into the principles of physics and engineering. When you push a tall vase, it seems to wobble and fall over with just a slight nudge. But when you push a short, wide box, it stays put, almost as if it's glued to the ground. Why is that? The key lies in the position of their center of mass and something called the base of support. The center of mass is the point where the mass of an object is concentrated. Imagine balancing a ruler on your finger. The point where it balances perfectly is its center of mass. This concept is crucial in understanding stability. The base of support is the area beneath an object that's in contact with the ground. Think of it as the object's footprint. The larger the footprint, the more stable the object. For instance, a chair with 4 legs has a larger base of support compared to a tall, narrow vase. If the center of mass of an object falls directly within its base of support, it's stable and won't tip over easily. This is why a short, wide box is more stable. Its center of mass is low and well within its base of support. But if the center of mass falls outside the base of support, watch out, the object will topple. This is what happens when you push a tall vase. Its center of mass quickly moves outside its narrow base of support, causing it to fall. That's why a wider base makes things more stable. A pyramid, for example, has a very wide base and a low center of mass, making it extremely stable. This principle is used in architecture and engineering to design buildings and structures that can withstand various forces without toppling over. Engineers and architects use these principles to ensure the stability of structures. Skyscrapers often have wide bases or deep foundations to keep them stable. Bridges have wide supports to distribute weight evenly and prevent tipping. Even in everyday life, understanding these principles can help you arrange your furniture or pack your bags more effectively. So next time you're arranging your living room or packing for a trip, remember, it's all about balance. Understanding the center of mass and the base of support can make a big difference in keeping things stable and secure. Thanks for watching. Stay tuned for more fascinating insights into the world of physics. Section 6. Center of mass versus center of gravity. Are they the same? Now, you might be wondering about the center of gravity. Is it the same as the center of mass? For most everyday situations, yes. Both terms essentially refer to the point where an object's weight seems to be concentrated. However, there's a subtle difference. The center of gravity is influenced by the strength of the gravitational field, which can vary slightly depending on location. Section 7. Calculating center of mass. Let's do some math. Don't worry, we won't get too bogged down in equations, but understanding how to calculate the center of mass can be helpful. For a simple two-object system, imagine two balls of different masses connected by a rod. The center of mass lies closer to the heavier ball. To find its exact position, we use a weighted average formula, taking into account both the masses and their distances from a reference point. Section 8. Center of mass. Your invisible friend in motion. The center of mass is a fundamental concept in physics that helps us understand how objects behave when forces are applied to them. The center of mass isn't just about balancing stationary objects. It's about understanding the equilibrium and stability of objects in motion. It also plays a crucial role in how objects move. For instance, when a rocket launches, its center of mass shifts as fuel is burned and expelled. When a force acts on an object, whether it's a gentle push on a toy car or a hammer striking a nail, the effect of that force can be analyzed by looking at the center of mass. It's as if the force is acting directly on the object's center of mass, simplifying the complex interactions into a more manageable analysis. This concept is essential for understanding phenomena like linear momentum and collisions. In a car crash test, for example, the impact forces are analyzed based on the center of mass of the vehicles involved. Imagine a cue ball striking another billiard ball. The collision and subsequent motion of the balls can be analyzed by considering the forces acting on their respective centers of mass. The center of mass helps us predict the paths the balls will take after impact, making it a crucial tool in both theoretical and practical physics. Understanding this invisible friend in motion allows us to better grasp the dynamics of everyday objects and complex systems alike. Whether it's a gymnast performing a flip or a diver executing a perfect dive, the center of mass is key to achieving balance and precision in motion. Even in the vastness of space, the center of mass governs the orbits of satellites and the rotation of planets. It's a universal principle that applies to all scales of motion. From the simple swing of a pendulum to the playful motion of a child on a swing, the center of mass is at the heart of understanding how and why objects move the way they do. So, next time you see a drone flying smoothly or a bird gliding effortlessly in the sky, remember that their invisible friend, the center of mass, is guiding their motion. Embrace the concept of the center of mass, and you'll unlock a deeper understanding of the world in motion around you. Section 9. Beyond the basics. Center of mass in complex systems. As we venture into more complex systems like the human body or a multiplanetary system, the concept of center of mass remains a powerful tool for analysis. For example, understanding the shifting center of mass of the human body during walking or running helps us comprehend balance and coordination. Similarly, astronomers use the center of mass to study the movements of celestial bodies, unraveling the mysteries of the cosmos. Section 10. Keep exploring. The center of mass adventure continues. Congratulations, science adventurers. You've now delved into the fascinating world of the center of mass. Remember, it's the point where an object's mass seems to be concentrated. Its balancing point. From balancing a pencil on your finger to understanding the motion of planets, the center of mass is a fundamental concept that governs our universe. So keep exploring, keep questioning, and keep the spirit of scientific discovery alive.